class, we are going to see about comparator. Comparator doesn't have a feedback connection. So this will compare two terminals we are having, non-inverting terminal, inverting input terminal. So any one terminal we will give the reference voltage, another terminal we will give the voltage which has to be compared. Based on the comparison, the op-amp will give an output voltage that can be used for various application. Here, that one general example where we can compare and use op-amp is temperature control. So if the temperature, we will have the references somewhere around 25. 25 we will keep it as reference. So if the temperature goes above 25, we have to switch on the AC. And if it goes below 25, we'll make the AC off. So to maintain the temperature, we should compare it with some reference voltage and we have to do some operation. Similarly, in agricultural field, depending upon the moisture level of the soil, we have to water the plants, otherwise not required. So there is a comparison we will do it. What is the moisture level? One value we will keep it as reference. Another value, the actual moisture of the soil will change. If the moisture level is less, we have to water the plants. We have to switch on the motor, water the plants. And when the moisture level is high, we have to stop watering the plant. So the comparison, we have to do it. To do the comparison, one terminal voltage, we will keep it as reference. Another will be the input voltage from the surrounding. And in comparator, there is no feedback. The circuit is not having a feedback. It will be an open loop configuration. Open loop means input and output, there is no connection. And how this will compare and give the output is, in the input, 1 minute. The input, we have 1 volt terminal, we will keep it as reference voltage. The reference voltage, we can keep it either in the non-inverting input or in the inverting input. So plus terminal is called as non-inverting input, minus terminal we will call it as inverting input. So any one terminal we will give the reference and one terminal we will provide the input voltage. When you do the comparison, every op-amp we will give a power supply, plus VCC, minus VCC. So the output voltage will be either plus VCC or minus VCC. We are not having any feedback. Open loop configuration, it will work. So the output will be the saturation voltage of the IC. Maximum output, what it can give, that output voltage, we will get it. And minimum what the op-amp can provide, that output voltage, it can give it. So the comparator, the circuit will work in an open loop configuration. There is no feedback between input and output. So it is called as open loop configuration. Here, depending upon the input voltage present in positive terminal as well as negative terminal, the output will be plus VSAT or minus VSAT. Ideal configuration, this ideal characteristics we will draw it. It will be plus VSAT or minus VSAT. And how we will do the comparison? It's very simple. Always the positive terminal. We are having two terminal voltage, positive terminal, negative terminal. When the positive terminal voltage is greater than the negative terminal voltage, positive terminal, we will call it as non-inverting terminal. And this one is inverting terminal. So when the positive terminal voltage is greater than the negative terminal voltage, the output will be plus VSAT. plus Vsat is the maximum saturation voltage what we will get it from the IC, and this will be approximately equal to plus VCC supply what we are giving it to the IC. And when the positive terminal voltage becomes less than negative terminal voltage, output will be minus Vsat. And this negative saturation is approximately equal to minus VCC, which is the power supply voltage we provided for an IC. So only this condition you have to remember for comparator. There is no circuit diagram, derivation, anything. There are two input terminals. If the positive terminal voltage is greater than the negative terminal voltage, the output will be plus Vsat. If the positive terminal voltage is less than the negative terminal voltage, output will be minus Vsat. So ideally, if we take the transfer characteristics means a characteristics which is drawn between input and output. The characteristics that is drawn between input and output is called as transfer characteristics. So x-axis will be the input. Here x-axis will be the input, y-axis will be the output. So if we draw it, the output will be varying between plus Vsat and minus Vsat. Based on the input, the output will be swing between plus Vsat and minus Vsat. This is for an ideal comparator. For practical comparator, to move from plus Vsat to minus Vsat, next circuit operation we will see. To move from plus Vsat to minus Vsat, it will take a small time duration. That small voltage difference it will take to move from plus Vsat to minus Vsat. This difference will be around 2 millivolt. This difference will be around 2 millivolt. There won't be sharp transition. When there is a change from plus Vsat to minus Vsat, there will be a, practically it will take some voltage level. That voltage level is called as, that voltage difference is 2 millivolt. This is for practical comparator. Ideal comparator, we will move from plus Vsat to minus Vsat instantly. But practically, it will take some voltage to move from, voltage difference to move from plus Vsat to minus Vsat.